Hazardous Communication and the Rhode Island Right to Know program. This video covers Rhode Island Right to Know for McLaughlin Moran Incorporated in Cranston, Rhode Island. OSHA, the Occupational Safety and Health Administration, requires employers to have a written hazard communications plan. Having a plan demonstrates our commitment to helping our employees work safely with chemicals that are in use in our workplace. Today's class will discuss the chemicals in the workplace, how to determine chemical hazards, and how to protect yourself in the event of a chemical hazard. We work around chemicals every day. Anything from filling your vehicle with gas, cleaning your bathroom, or maybe even using some spray to protect your garden. All of these chemicals are rendered safe by use of proper handling, their delivery method, and by proper storage. These are all examples of why we're conducting this class. We want you to be able to work safely with the hazardous chemicals at work as well as at home. As long as you understand the hazards and know how to protect yourself, working with these chemicals can be done safely every day. The goal of this training is to make sure you have a complete understanding of several areas of the Right to Know program. You need to know the program itself, personal protective equipment, first aid, spills, and leaks, as well as how to read an MSDS or Material Safety Data Sheet and all the labels associated with it. OSHA created the Hazard Communication Standard to help ensure your safety when working with chemicals. The standard requires your training to include a discussion of the operations that use hazardous chemicals here at McLaughlin Moran, how to detect the presence and release of a hazardous chemical, the physical and health hazards associated with working with them, and how you can protect yourself in the event of coming into contact with a hazardous chemical. This training will cover all of the basics required in all these topics. And at any point, you can email any questions to wrobillard@mclaughlinmoran.com. Everyone involved in the dealing of hazardous materials is responsible for several facets of keeping those that deal with them directly safe. The manufacturer of these chemicals have to determine the physical and health hazards of the products they make. They have to properly label and make readily available any MSDS that is required. The employers have a responsibility to provide a written hazard communications plan, a list of any chemicals that we use, provide any MSDS for any chemical that we have on site, and also offer the training that you're receiving now. Employees have responsibilities as well. You're required to read any label and an MSDS with any chemical that you work with. You have to follow our instructions and warnings for using those chemicals. If you see a hazard, it's your job to identify it before starting a job. And you have to participate in any training required in the use of those chemicals. Now that we understand our responsibilities, let's move on with our training. Most people understand and recognize physical hazards and how to protect themselves against them. You don't smoke around a propane tank or around gasoline. However, few people recognize and understand chemical hazards and, therefore, don't know how to protect themselves. Sometimes the effects of hazardous chemicals are not felt immediately. Therefore, appropriate precautions are not taken. Physical hazards include fires or explosions, sudden releases of pressure, or reactivity. This is when a chemical can burn, explode, or release a gas after contact with another chemical, even water. Let's talk about some of the examples, both work and at home, of each of these categories listed under physical hazards. Some examples of flammable chemicals include acetone, propane, gasoline, and paints. Although gas, paints, and propane are things we use often, something like acetone might not be recognized right away. Acetone is the active ingredient in nail polish remover, and just like the other chemicals, is very flammable. Examples of explosives include compressed gas cylinders, such as the type used on forklifts, and aerosol cans. Reactive chemicals. This is what happens when two or more chemicals mix together to form a hazard. One of the most easily recognized of these is the mixture of bleach and ammonia, which is extremely dangerous. Health hazards include illnesses or other health problems that could develop as a result of overexposure to a chemical. Short-term effects include headache, dizziness, and skin irritation. Long-term, these effects could be liver or lung damage, or even cancer. Let's talk about examples from both work and home of each of these categories listed under health hazards. Corrosive. An example of a corrosive is nitric acid, which is present in many household cleaners. And then you have toxics, which include pesticides, the benzene found in gasoline, a lot of solvents that we use to clean, such as brass cleaner, and then lead, mostly found in lead-based paints in older homes. The manner by which a chemical affects us is called a route of entry. When a chemical makes contact with our skin or eyes, it can cause several different effects. Irritation, which can cause itchiness and blisters, is often caused by solvents, degreasers, and soaps. Corrosives can cause burns. Internal reactions, which is an exposure to a toxin, are caused by hydrocarbon or solvents. An allergic reaction, which are hives, can be caused by chromates or nickel. Inhaling chemicals can cause headaches, nausea, dizziness, and lung damage. Swallowing. This usually means contact with food or smoking, not openly drinking a hazardous chemical. Swallowing a hazard can cause nausea, vomiting, dizziness, liver or kidney damage. Then there's penetration. This is the introduction of chemical with a sharp object or needle. Dosages. This is the amount of chemical exposure. The MSDS will list the dosage or exposure level allowed for each hazardous chemical. These exposure levels are typically called permissible exposure levels, or PEELs, as set by OSHA, or the threshold limit as recommended by the American Conference of Governmental Industrial Hygienists, and referred to the quality of hazardous chemical that an average employee can safely be exposed to in an 8-hour workday. This is just like your doctor telling you to take 1 pill every 8 hours. If you take 2 pills in the 8-hour period, you're technically overdosing and could suffer the same side effects. The company works to maintain exposure levels below these levels with engineering controls, ventilation, and personal protective equipment. Overexposure to a chemical can cause 2 types of effects, acute and chronic. Acute effects are short-term effects or symptoms that disappear once the victim is no longer exposed to a chemical. They include rashes, burns, respiratory irritation, and poisoning. Chronic effects are long-term effects that develop over a long period of exposure. These include allergies, lung or liver damage, and cancer. Now we move on to personal protective equipment. Dust masks and respirators are used when working in an environment with hazardous dust, vapors, liquids, or gases. Anyone who uses a respirator as part of a normal job must be involved